In 9.3, we're going to be dealing with surface area and volumes of prisms and cylinders. Now, the type of prisms that you'll be dealing with, there are triangular prisms, there are rectangular prisms, there's going to be even a hexagonal prism and a trapezoidal prism. They are named by their base. And so what we're going to have to do is we're going to figure out what the surface area is of these shapes, and volume is so much easier than finding the surface area. Surface area is actually harder. Here, our worksheet's actually going to recommend that we add up all the areas of each of the faces or the sides and just put those together. And this morning, while I was awake really early this morning, I did the worksheet that you guys are going to be doing for your homework, and I didn't really add up every single individual area. What I used was something slightly different, and so if you want to use this instead of what the worksheet recommends, then you should probably write it down. Let's see what it is. It goes draw, red. I was using twice the area of the base, surface area equals twice the area of the base plus the perimeter of the base, times the height. That's what I was using. And I'll give you an example in just a moment. I used twice the area of the base plus the perimeter of the base times the height. And I'll give you a small example of something that I did a problem with. Here's this, and then here is this, matching, connect, connect, connect. That is not a great drawing, but there you go. This would be a triangular prism. And so when you're dealing with a triangular prism, the bases are the pieces that match up with each other. So the base is this end that matches up with this end. Do not necessarily think it always means the top and the bottom. If I have this side or this shape that matches up with the other side, that is what your base is, even if it's the front and the back of the three-dimensional shape. And so when we find the surface area, what I did was I figured out what the area of this base was. What I figured out what the area of that base was, I would just double it, and so that would be two of the sides. And then whatever the perimeter is of this base, multiplied by the height. The height would be the distance from one of the bases to the other. So that would calculate all the area around those triangles. That's kind of what I used, and I'll show you an example as we go. It doesn't matter which faces are the bases in rectangular prisms. That's the only one that you can get away with doing any side. Doesn't matter. But for the triangular prisms or the hexagonal prisms, make sure that the two bases are the ones that match each other. Volume will be a lot easier for us to figure out. Volume is calculated by multiplying by the area of the base times the height, where the height is the distance between the two bases. And so then I gave you several formulas that you will use throughout this section. If you're trying to figure out the area of the base, if the base is a triangle, you'll use this part first, multiplied by the height, rectangle, trapezoids, and so on. The last thing that we wrote down was about composite figures. Composite figures are usually composed of two or more shapes, and so they're going to expect you by the end of this unit to be able to subtract areas or volumes and add them as well using your brain. So I have 3 examples now, I think. Yes, I do. 3 examples. Number 5, number 9, and number 19 are the ones we're going to do. If you would like to do it in your notes, you are welcome to do so. Or if you want to do it on your worksheet, you're welcome to do that as well. First thing I need to find is the surface area. This is a triangular prism. So the first thing I need to do is figure out what the area of this triangle is. In order to find the area of that triangle, I need 1/2. I'm going to just do area of the triangle real quick. Is 1/2 the base times the height. The good thing is I know what the base is. But the height has to be perpendicular. I need this height, not the 10. I need this height. The 10 is not the height. The 10 is the slant height, I guess you would say. So what I have to do then is I have to put a little 3 here and then a 3 there, because since this side is 10 and this side is 10, these two things are the same as each other. They're isosceles. And what I have here is a right triangle. This is what I'm really looking at here. I'm looking at a 10 and a 3, and I want to know what that H is. You only know two sides. This is not a 30, 60, 90. There's nothing here that proves that it's a 30, 60, 90. So what we have to assume is we know two sides of a right triangle, and we need to find the third. I would use the Pythagorean Theorem. 3 squared plus h squared equals 10 squared. H squared equals 10 squared minus 3 squared. H equals the square root of 10 squared minus 3 squared, or 100 minus 9. H is equal to the square root of 91. I'm not rounding it yet. So now what I have is I have the area of one of the bases. Now if I want the area, the surface area of the whole thing, I need the front base, the back base, the right side, the left side, and the bottom of this whole triangle. Triangular prism, I should say. That's why I use that formula, twice the area of the base. Two of these. And then what I used was the perimeter of the base times the height, plus the perimeter of the base times the height. So now let me look at this. The perimeter of the base going all the way around this thing. What's the perimeter of this thing? 10, 6, and then this other side's 10, so that makes this 10. What's the perimeter? Hopefully you see it's 26. And then this height. This is the distance between one base and the other base. 24. So I'm going to plug all this stuff into my calculator. 2 times 0.5 times 6 times root 91 plus 26 times 24. And then what I like to do, as I've told you before, is I like to look and see, did I type it in correctly? Because let's say I'm tired from my lack of sleep last night. Equals nearest tenth, 681.2 inches squared. Surface area is squared units. There are other ways to do it. You could calculate this area plus that rectangle plus that rectangle plus that rectangle. If you want to do it by the parts, you're welcome to do so. For me, this formula is easier. Twice the area of the base plus the perimeter of the base times the height. Volume is much easier. Volume is a simple formula for all shapes. The area of the base times the height. Now the nice part about number 9 is it's a rectangular prism. I can choose to have the bottom as the base. I can choose to have the right side as the base. Any side can be your base for a rectangular prism. It's the only one that I can get away with it. So let's say I have this side as my base because it doesn't really matter. The area of the base would be 8 times 12. The height is the distance from this base to the matching side. From this side to this side, this must be your height if the right side is your base. And it wouldn't have mattered if you chose the bottom as the base because this times that is going to be the same thing. Volume is basically length times width times height for a rectangular prism. So I take my calculator, 8 times 12 times 10.5. I make sure that I typed it in correctly. I press equals, and I'm rounding to the nearest tenth. And since we're talking about volume, we're talking about cubic units. Yeah, student services. Last example. This is a composite figure. A composite figure sometimes will have one whole thing, sometimes it'll have something missing, and then you have to use your common sense to figure out how you're going to do it. This is a cylinder with part of this cylinder cut out or missing. If I were to find the volume of just the cylinder, it would be the area of the base times the height, where the area of the base would be pi r squared times the distance from one base to the other. That would be for a whole cylinder. Is this the whole cylinder? Do you know how much of the cylinder this is? If you're not sure, let's think about what we did in section 2. In section 2, we learned that this is how many degrees from here to here? Out of how many degrees? So I'm just going to write down that it's 270 degrees out of 360. And I already know what that reduces to, even without doing any math, because I can just look at this and go, oh, I know exactly how many pieces this is because I saw my little elementary school teacher do something like this, and I can see how many of the pieces it's cut into and how many we have. What's the fraction? And then what I like to do is just go, I'm pretty sure that's what it's going to be on the calculator. Just to double check it. And this is 3/4 of the area of the base. The area of the base is pi r squared. What's my radius? 5 squared. What's the height? The distance from this base to the other is 10. So there is my work. And so let's see, I have to do exponents first. 250. I need to do 3/4 of that times pi to the nearest tenth times 250 times pi. Nearest tenth, switch it to a decimal, 589.0 feet cubed. Cubic feet, because we're talking about volume. Any questions? We'll end your notes right there.